Welcome. So I want to give some examples of functions that are not continuous everywhere. So there'll be a particular value, x equals a, where they're not continuous. And the first one that I want to give an example of is a function that's undefined at x equals a. Okay, so we have our x-axis and our y-axis. And let's consider the function, which is going to be f of x equals 1 over x. So its graph is going to look like this. So this is f of x equals 1 divided by x. Okay? And over here, it's going to go like this. And if we look at x equals 0, right? Then because our function goes infinitely up, so it approaches infinity, it's not actually defined there. Okay, so what's going on here is that f of x equals 1 over x. Okay, so this function is not defined at x equals 0, so is not defined at x equals 0. Okay, so what does that tell me? So we know that f is not continuous. So f is not continuous at x equals 0. And all it takes is to not be continuous at one point in order to be not continuous. So right, f is not a continuous function. Okay, so f is not a continuous function. Okay, so what went on here, so why isn't this a continuous function? In particular, it's not continuous at x equals 0. And the only reason it's not continuous, and particularly not continuous at x equals 0, is because it's not defined at x equals 0, because its values become infinite. There's other ways you cannot be defined, but that's one of them, is your values either become infinite positive or infinite negative. We'll really approach infinite positive or infinite negative, or you just don't give the value or something. So really x equals 0 is not in the domain. Okay, so I hope that was a little helpful, made some sense, and I will see you in the next lecture. Sure.